In the videos you were assigned last night, we talked about ways to solve quadratic equations. I know at most we're going to have two solutions. Those solutions, if we actually graphed them, would be where does the function cross the x-axis visually. So I went over two different ways in the videos that you can use factoring as a method. Now factoring will not always work for every quadratic equation as a method to solve. This one will work. So I'm going to show you two ways. I'd like you to write down both methods. Here's the first method. They both require us to make what looks like this elongated x. I'm going to take the a times the c. So I have, oh my goodness, I'm going to take 6 times positive 10 to get a positive 60 and a positive 17 down below. And I'm asking myself what two values multiply to give us 60 and combine to give us 17. And those two values would be 3 and 20. Now let's check here. 3 and 20, yeah, they give me 60. But look at the only way to get 17 would be to subtract them, which means I would need to have one positive and one negative. So one of these combinations, but then that doesn't give me a positive 60. That does not work out, right? That doesn't work out. So let's try other combinations. Let's go 1 and 60. That doesn't work. What about 2 and 30? That doesn't work. 3 and 20. That doesn't work. 4 and 15. That doesn't work. 5 and 12. There we go. So positive 5 and positive 12. They multiply to equal positive 60, to combine to give you a positive 17. Those are going to be the keys as I show you two different methods in order to factor and solve. You'll choose what method makes most sense to you. Let me grab a pencil here. Maybe it'll show up a little bit better in the dark. So here's what is called the AC plus B method, or factoring by grouping. So you write out the A, you write out the C, and now I'm going to drop into this place the 5 and the 12. And don't forget, they both need to have an X behind them always. Okay, so how do I go about doing this? Factoring by grouping. What's the most you can factor out of a 6 and a 5? A 1. But I can take out an X. 1 times 6 is 6. I need two X's. Again, I'm just building upon all the notes you took last night. 1 times 5 is 5. We already have an X. There's 5X. So if I distribute, I end up with 6X squared plus 5X. I take what's in parentheses and I rewrite it again. And I ask myself, is there a value I can take times 6 and end up with a positive 12x? There is. A positive 2. 2 times 6x is 12x. 2 times 5 is 10. Now there's a left side and a right side to this. Okay, this looks good. Notice they both have the 6x plus 5. I write it down only one time. Then I ask myself, what's in front of the first? 1x. What's in front of the second? A positive 2. And I said both of these equal to 0, and I solve. And you literally have to show all of your steps. And I know that's sometimes painful for students, but I'm doing that right now. Make sure you have a calculator in front of you. I'm going to demonstrate why coming up next. And I subtract 2 to both sides, and I get negative 2 divided by 1. I get x equals negative 2. Take that calculator that's in front of you, please. If you haven't grabbed one, you need to go grab one. I'll press pause. Hey, you ready? So students in my class, they just ran and grabbed a calculator, and you're asking yourself why. In the video, I talked about extraneous solutions. What does that mean? It means you do all of the work. It looks great. You believe these are the answers, but now you have to check when you plug it in, does it work? Grab your calculator, please. I'm going to teach you now how to use the calculator to make this easy. Whenever you substitute in a value, it has to go in parentheses. So I have parentheses around the negative 5/6. I'm squaring it. Then I'm going to do parentheses around again, the negative 5/6 plus 10. So I just took to the left side of this quadratic equation. I substituted what I believe is a solution, and it must equal 0 if this is a solution. Awesome, it does. I just checked it. I'm going to put a star. I checked it. I'm going to do the exact same thing for negative 2 right now. As a reminder, whenever you substitute in a value, it must go in parentheses. I substituted negative 10. Awesome, it worked. So as we move through this, just know that your test as well, much of your test for the Unit 2 is non-calculator, okay? So I'm going to do another way to factor, and this is called the bottoms-up method. You could choose to use this method, AC plus B. You don't need to memorize the name of it. Or you could use the method I'm going to demonstrate. Now, why do I like this method better? Because it's less work. So here what we're going to do is we're going to make our parentheses. I've already selected 5 and 12 as the values that multiply to give us 60 and combine to give us 17. So I drop in the positive 5, I drop in the positive 12. Now, I always have to go up to the leading coefficient. I'm going to put that underneath both values. And then I want to ask myself, can these fractions be reduced? Now, I'm just showing in a calculator how you can test that. Please take 5 divided by 6. And once you've done that, on the left-hand side, find the button that says Math. And after you press it, press Enter twice. When you press Enter, we come up with 5/6 again. That means 5/6 cannot be reduced. Circle the 5/6, including the plus sign. But notice, I know you can take 12 and divide it by 6, but now take 12 divided by 6, hit Math, Fraction, Enter, Enter, and notice that 12 over 6 does reduce down to positive 2. So after you reduce both fractions, as I shared in the video, you then will move forward. With circulating the value and the sign in front. What's next? Well, what's opposite of positive 5/6? Negative 5/6. Done. What's opposite of positive 2? Negative 2. Done. And notice, we've already checked negative 5/6 and negative 2. We know they both work. So you get to choose whatever method you want. Remember, factoring will not always work. The next one I want you to do is please write now with your partner, write down the quadratic formula. Go. Write down the quadratic formula. We're going to do just a slightly different version of this. Here's the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Quadratic formula, you do have to have it memorized. It's okay if it's not memorized now, but over the course of the week, you do need to have that memorized. You're thinking, like, what did she just do? This is the same equation. It just looks a little funky. So what we need to do is we need to reorganize it. So I have the a, that's the value with x squared on the left. I need to bring this over. Especially if you've had me before in class, when it crosses over the equal sign, what does negative 17 become? Negative 17x becomes positive, but when it crosses over, it changes signs. So it no longer is on the right-hand side. We still have the 10, and now I have my A, my B, and my C. So I'm going to go ahead and make my parentheses where I'm going to input in the A, the B, and the C. So my A is 6, so A goes into these two positions. My B is 17, so 17 goes into these two positions, and my C is 10. Now, as I spoke about in the video, so that's where the learning is going to happen. The learning has to happen outside a classroom with the flipped room, and that's why there is the detention for 30 minutes when you don't keep up, as a way for you to help to start incorporating those good, healthy habits. Okay, are you ready? This is called the discriminant. We are now going to plug that in. We're not going to include the square root. So we have 17 squared. Subtract 4 times 6 times 10, and I end up with 49. So let's write this down. I have x equals negative 17 plus or minus the square root of 49 over 12. In the video, I talked about the discriminant. When the discriminant is a value that's greater than 0, it's a positive greater than 0, we are going to have two solutions. That means two x-intercepts. So I know that the square root of 49 is 7. You could use a calculator to figure that out. So one time I'm going to add, and the second time I'm going to subtract. So negative 17 and positive 7 is negative 10 over 12. We know that reduces to a negative divided by 2 and divided by 2 and negative 5/6. Here I have negative 17 and negative 7. That's going to be a negative 24 out of 12. That's going to reduce to negative 2. And you're thinking, well, Miss Bradley, do I still need to check those answers? You would always check them. The reason I'm not checking them is I'm using the exact same equation 3 times. I've already checked those values. So that's why I'm not taking time and wasting your time to check.